All right. Hey, everyone. Welcome to day 13 of Math 133. Today, we're going to cover the Chapter 6 review, and that's it. So there's no lecture notes that are assigned. The midterm is coming up. It's going to be next week, and the midterm covers chapters 1 through 6. Okay. So we have reached to the end of all of our material. So we're going to do the chapter 6 review today. And then we're going to work a little bit on our sample midterm. So the sample midterm is due October 16th. So you'll see that on Tuesday, October 14th, there is no class. So we're not actually covering the sample midterm exam. But if you click on this, day 14, you'll see the sample midterm. You can click there and be able to get to it. The sample midterm is in your course pack, starts on page 424. But we're going to be covering the Chapter 6 review today. So any of the stuff in the sample midterm that we don't cover, Cindy will be able to cover with you guys next week on Monday and Wednesday. So we actually have 2 days that she'll be able to help you out. So make sure you come to that. Um, so the midterm is on October 16th if you're taking it with me in Zoom. And so if you take it with me in Zoom, you'll click on Thursday, October 16th, and then you'll submit the survey, or sorry, not the survey, the exam. We already did the survey. You'll submit the exam just like submitting your normal worksheets. Okay, so you'll use Cam Scanner and scan it in. Try to make it one document. I know some people have been posting one page at a time with their cam scanner, and that's fine for like a worksheet, which is only 4 pages, but the midterm is 9 pages. So I mean, I guess if you have to submit 9 documents, it's fine. But if you're not sure how to do it, Cindy can show you how to make a single document out of your scans. You'll also notice on day 15, which is the day of our midterm, we are assigning lecture notes. So 1.3, 4, 5, and then 7.1, 7.3. So you'll want to do those before Monday, October 20th, because that's when Cindy's going to cover some Chapter 7 stuff with you guys, okay? But also, we'll start working on Chapter 7 on Tuesday, October 21st. So I just want to point out the lecture notes are being assigned because um, we don't have class next week on Tuesday. And some of you might be taking the test at the testing center. So this is actually the last time I'll see you before October 21st. So um, anyway, so feel free to work ahead on the lecture notes. So I'm telling you about the lecture notes now. You don't have class on Tuesday, this upcoming Tuesday. So you could use that time to work on the sample midterm, but you could also use that time to work on the lecture notes. Okay. You're welcome to work ahead in this class. It's easy to fall behind. And so the best way to keep up, the best way to keep from losing points is to work on those ahead of time. Okay. Um, okay, so if you are taking the midterm at the testing center, you can take it next week on Tuesday. We don't have class, but I did verify that you can take it Tuesday, October 14th at the testing center. Tuesday, Wednesday, Thursday. If you're taking it Friday at the testing center, their hours are a little shorter. So they have hours from 10 to noon, and you're going to want to contact them if you're taking it Friday, October 17th, to make sure that that they will be able to fit you in. Okay. Um, so at the testing center, you will get handed a paper copy of the test, and you'll fill out your answers, and you'll be fine. Okay. By the way, if you're taking it at the testing center, so at the top of the midterm, there'll be a link, https:// and then you'll need to type that into your browser so that you'll be able to get to the data sets. Okay. For those of you taking it on Zoom, I will send this to you and you'll be able to click on this and I'll show you where it takes you. So it's going to take you to a site that looks like this. Why is it being weird? Mm, hold on a second. All right, so if I click on this, it's not listening to me. There we go. If I click on that link, it'll take me to a Google document, which has two links. One of them is a link to a Google spreadsheet for problem number 2. The other one is a link to the data in StatCrunch. So you'll click on that, and you'll click on that. And when those open up, so here's the data that you'll fill in, and also, well, I'm not signed in here, so you need to make sure you're signed into StatCrunch. So, all right. So make sure you have your StatCrunch sign in handy for Pearson. Okay. All right. Okay, so if there's any questions on the midterm, let me know. We talked a lot about it last time, so I'm just gonna keep moving forward if that's okay. By the way, one of the things we mentioned is if you're taking it with me in Zoom, I will send it to you and you can print it off, or you can uh, leave it up on your screen and write your answers on a blank piece of paper, and you'll scan that blank piece of paper in. Okay. For the testing center, if you're taking it on Tuesday, Wednesday, or Thursday next week, it's just walk-in time. So you can just come in when they are open, and yeah, you're good. So they are open, let's see here. Um, Drop-in hours Monday through Thursday are from 9 a.m. to 6 p.m. So you have lots of time if you come to the testing center. Okay. Fridays, they're open 10 to 2. Okay. So, yeah, for the walk-in hours, you just walk in and say you're here to take the Math 133 test and you'll be fine. Okay. Okay, cool. So, uh, chapter 6 review is on page 408. Page 408. Nyla, there's no link for the worksheet right now. We are going to work on page 408 in our course pack. I was just showing the link that you'll need for uh, the midterm. So on the day of the midterm, you'll click on that link or you'll type it in your browser. So, um, all right. So let's see here what we've got. So chapter 5 was all about probability. Chapter 6 is all about probability distributions. Okay. So very closely related. Um, the discrete probability distribution here shows the number of major cities in each state in the US. So explain what must be true in order for this to be a valid probability model. So there's two parts. First of all, in order for it to be a valid probability model, all of these numbers have to add up to 1. So I'm going to write it in math. So this is a capital sigma, and it means sum. And then this is the probability of an event X. So if you add up all the events, add up all the states, you get 1. Okay? 100%, 1. The other thing is that probabilities all have to be between 0 and 1. So if these two things are true, you have a valid probability model. Okay. So you didn't have to write it in math. You could have written as the probabilities sum to 1. You could have written those words. Okay. And then you could have written probabilities are between 0 and 1. That's fine. All right. Um, let's see. So Da, 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 da. Um, this one down here, part H, find the expected mean and the standard deviation of this probability model. Okay. So on page 254, there are three methods. The first method is if you have a raw data set, which is data in a single column, okay? Uh, if you have a frequency distribution, that's method 2. And we finally get to talk about method 3. Method 3 for calculating mean and standard deviation is if you have a probability distribution, okay? So that is what we have here. It's very closely related to the frequency distribution. Technically, it is. Both of them are weighted averages. The frequency distribution is doing a weighted average with frequencies, and the probability distribution is actually doing a weighted average with relative frequencies. But anyway, we're going to do method 3 on page 254 for this, okay? So it says that we're going to enter the x values. So let's see here. Let me write it down. We're going to enter the x values in a column and the probabilities in another column. Then we're going to use StatCrunch and we're going to do stat calculators custom. Okay. So I'm going to pull up StatCrunch here. So for chapter 6, we have our list of all of the different data sets, but you notice for chapter 6 there isn't any. So we're just going to go to statcrunch.com and sign in with your Pearson account. And once you sign in at statcrunch.com, this orange button in the middle will light up, and you'll be able to click on that, and it'll take you to a blank worksheet. So this is where we're going to just enter our information. So first, I'm going to enter the x-axis 0, 1, 2, 3, 4, 5, 6, 7. So, and I know it's 7 plus, but we're just going to put 7. Okay. And this is the number of major cities. Okay. So each state has a certain number of major cities. And then the probability of each of those is 0.34. So that says that 34% of states don't have a major city. So I guess maybe Montana. I can only name one city in Montana, the capital. Wyoming, I guess I can only think of Cheyenne. I don't know if that counts as a major city. Um, what would Michigan have? Michigan has Detroit, and
Grand
then
Rapids,
Grand
Lansing,
Rapids is the second one. So Lansing is probably a major city, right? And then Ann Arbor, right?
Ypsilanti, Traverse City,
I don't know if I don't know if Ypsilanti would count as a major city. I think it's 4. I think Michigan's 4. I don't know. We can argue obviously on it. Depends on what you define, like what you have to define it as. But um, okay. So here's our probabilities. And so method 3, we hover over stat and then calculators and then custom. The values are going to be these whole numbers. Okay, so the values are going to be discrete. The values are the number of cities, and the weights are your probabilities. Okay, and when it compute, gives us a nice little graph here. What I want though is the mean 1.58 and the standard deviation 1.856. There we go. Find the mean and the standard deviation. Okay. Interpret the mean and the standard deviation. So a state is expected to have 1.58 major cities, give or take 1.856. Okay. Cities. Probably put units on that. There we go. I put units on that. All right. Um, Question two is pretty much the same thing. We have a probability distribution here. Our probabilities sum up to one. Find the expected mean and standard deviation. So you're going to use page 254, method 3. Okay. And then interpret the mean. So same thing, our give or take script. Okay. Baccarat is a casino game where the players bet on which hand will be higher. Uh, Unlike many casino games, it's possible for there to be a tie, and um, you can bet that you're going to tie with the dealer. Um, so the casino payout for the tie bet in eight deck Baccarat. So if the player's higher, dealer's higher, or a tie, it's -1, and 8. So here we have the player higher, dealer higher, and then those profits are -1, -1, and 8. So if you're betting that you're going to tie, you lose $1 if you're higher, you lose $1 if you're lower, but you get $8 if you're right, if you tie with the dealer. Okay. Um, this is a probability distribution, a valid probability model, which means that these three numbers have to sum up to 1. So I have this number and this number. I'm missing this one. So I just need to take 1 minus this and get my probability there. So can somebody do for me 1 minus 0.446247 and minus this guy as well?
0.095156.
Normally, we don't want 6 decimal places, but we're going to use 6 decimal places here since the other numbers are listed out that far. Okay. Um, for part B, calculate the expected profit. So what you'll do is, so 44% of the time you're going to lose $1, 45% of the time you'll lose $1, and 9% of the time you'll gain $8. So you multiply these two numbers, and these two numbers, and these two numbers, and then add them up. That will give you your expected profit. That's actually the same thing that page 254, method 3 is doing. It's doing a weighted average where it takes each of these numbers, multiplies them, and then sums them up. Okay, that's what a weighted average is. So it's very similar to a normal average, where normal average you add them up and then divide by how many numbers there are. Here you are adding them all up after you multiply, and the division is already done for you in the probabilities. Okay. Um, right. Okay, let's move on to the next page. You're gonna roll 3 6-sided dice that have weights inside them, so that they roll a 6 75% of the time. Okay, so these are not fair dice. Okay, these are loaded dice. Interesting. Um, so why is it not appropriate to use the binomial distribution for the variable x in these scenarios? So on page 256, we talk about binomial probability experiment info. An experiment is said to be a binomial experiment if these four things are true. First of all, uh, it has a fixed number of trials. Okay, so you can't play forever. You do it for a fixed number, and then each repetition of the experiment is called a trial. Okay. The trials are independent. That means that they're not affected by outside things. Okay. Also, for each trial, there are two disjoint outcomes. So, success or failure. Success doesn't always mean it's positive. Failure doesn't always mean that it is negative. Okay. But there's only two possible results. Okay. You did it or you didn't. And finally, the probability of success is consistent for each trial. So, it's always the same. Okay. So, for this one, uh, part A, B, and C are not valid. Why not? So, suppose there's a way to use a magnet so that a person in the room can affect the dice rolls. You're going to toss the dice 10 times. Let X represent tossing a sum of 18. So, this is either not a fixed number of trials, or it's not two disjoint outcomes, or the trials are not independent. Okay. Any thoughts on this one? Well, first of all, do we have a fixed number of trials? Yes. We're going to roll the dice 10 times. That's it. We're not going to do more or less, so it's not that one. Do we have two disjoint outcomes? Well, what we're trying to do is we're trying to roll 18. If we succeed on that, that's considered a success. If we roll any other number, that's called a failure. Okay? So we can either get 18 or not. So there are two possible outcomes. The issue here is that these trials are not independent because they are being affected by an outside force. They're being affected by this magnet, right? So we said that they were a 75% chance, but the magnet is going to change that result. Okay. Second of all, part B, you're going to toss the dice 22 times. Let X represent the sum of the three dice. This is also not a binomial uh, probability experiment because, well, first of all, do we have a fixed number of trials? We do. We're going to roll 22 times. Um, However, in this case, do we have two different outcomes? So X is the sum of the dice. So the dice could add up to 3. They could add up to 18. They could add up to 10. They could add up to many different numbers. Okay. So in this case, we don't have two disjoint outcomes. We have lots of different outcomes. Okay. If they had said, we're trying to get a specific number, then fine. Okay. Or we're trying to get an even number. So you have your evens are your successes and your odds are your failures. Okay. That's not what they're doing here. So, all right. Part C, you want to get a sum of 18. Let X represent the number of tosses it takes to get to 18. So you can probably guess the answer here. So the problem here is how long is it going to take you to get 18? How many times are you going to roll the dice? Well, you could roll the dice once and get 18 right away. Or you could roll the dice 100 times and, oh, come on, I'm not getting 18. And so we don't know how many times we're going to roll the dice. This one we said we're rolling 10. Here we're rolling 22. Here we're rolling no idea. Okay. All right. There's more information on these probability binomial experiments on page 256. Most of these you're going to do in StatCrunch, and it's pretty easy to do as long as you know where to put things. So we'll come back to those. Down here, following are all graphs of a binomial distribution where n, that's our number of trials. So we're going to roll the dice 260 times, label each graph with its probability of success. So the probabilities are 0.1, 0.5, and 0.9. So the mean of a probability distribution, of a binomial probability distribution, the mean is right here. It's n times p. So that's going to be helpful for solving this one. Okay. All right. On page 411, CDC has found that 12% of US teens have been bullied online. You're going to randomly select 180 US teens. So that's our number of trials. We have a fixed number. We can presume this quantifies as a binomial experiment. Okay. So find N, P, Q, find the mean. So the mean, we just did it. We just said it, talked about it a second ago, is N times P. The standard deviation is the sigma, and that is the square root of N times P times Q. Okay. When you're putting this into your calculator, make sure you put parentheses in the right spot. You're gonna need parentheses around the stuff inside. Desmos, if you're doing it in Desmos is smart enough to know where those parentheses go, but your calculator might not be. So, okay, I think that's it. So, we'll stop the recording. We'll jump back to page 408 and we'll answer questions from the chapter 6 review.